Hello everyone. Today we will discuss the interesting topic, that is your applications of derivatives. Actually, it is the second part of this application of derivative class, and in the previous part we discussed what is a derivative, and next is rate of change and velocity, how to find velocity, how to find acceleration. If s of t, that is your position, is given, then how to find velocity, how to find acceleration. Now we discussed rate of change, means in the previous classes already we have discussed rate of change of area of a square. Then rate of change of area means we solved the problem. Then we solved the rate of increase of volume of a sphere, question on this. And next we solve this question in the next slide. And next we again same thing, we solve the next we solve tangent and normal to plane curves, how to find its slopes. Then after finding slope, we find the tangent equation and the normal equation to a curve. Then we solved a problem, that is to find the equation of tangent and normal. And next we discussed the increasing and decreasing function, and this is which is called monotonic function. And we discussed in part 1. Okay, so now in this part we will discuss the maxima and minima. We will discuss the maxima and minima. So first, the definition. What is the definition? Local relative maximum. Local relative maximum. So a function f is said to have a maximum at a point x equal to c if fc greater than fc plus h for 0 less than mod h less than delta for some delta greater than 0. That means your h is in between minus delta to delta, is not it? So h is a positive number which is greater than 0, the fc greater than f of c plus h. Then we say that function is maximum at the point x equal to c. This is actually relative maximum or local maximum. Then for absolute maximum, the definition is what? The value f of c is said to be an absolute maximum. F of c is said to be an absolute maximum if f of c greater than equal to f of x for all values of x. Just note it down, for all values of x for which f is defined. So f must be defined for that values of x, and for each value f of c must be greater than equal to f of x. So if f of c is greater than equal to f of x for all values of x, then we say that f of c is absolute maximum. F of c is the absolute maximum. Next come to another definition for the local minimum and absolute minimum. This is just opposite to the definition of absolute maximum or minimum, absolute maximum and the local minimum maximum. So what is the definition? A function f is said to have a minimum at a point x equal to c if f of c less than f of c plus h. Is not it? But it was in your local maximum, it was f of c greater than f of c plus h. Next is absolute minimum. So f of c is said to be an absolute minimum if f of c less than equal to f of x for all values of x for which f is defined. But in case of absolute maximum, it was what? F of c greater than equal to f of x. This is your absolute absolute maximum, absolute maximum. But in case of absolute minimum, your f of c less than equal to f of x. Okay, so now what are the extremum and necessary conditions? What are the extremum and necessary conditions? What are the conditions so that the value will be extremum values? That means it may be maximum or minimum. So extremum value means extrema. It is also called, the plural of extremum is extrema of a function. It is either maximum or minimum. So what is the meaning of extremum? So meaning of extremum is it may be maximum or minimum. So it is the extreme value. Extreme value is it may be maximum or minimum. The next is what is the necessary condition for an extremum? So if f has an extremum, at x equal to c, then f dash c equal to 0 or f dash c does not exist. Okay, so for the extremum, if f has an extremum, then your f dash c must be 0. The first derivative at the point c must be 0 or it does not exist. Okay, so this is the necessary condition. If f dash c suppose not equal to 0, then f has no extremum. If you take the contradiction of this statement, if f, suppose we write f dash c not equal to 0. Suppose we write f dash c, your f dash c will be not equal to 0, then we can say also f has no extremum. Okay, so what is the necessary condition? If f has extremum, then f dash c must be 0. Or f dash c does not exist. Next is critical point. So these are the theories we have to remember. Okay, so these are the theories, and after this theory we will solve some problem. Next is critical point. So what is critical point? So critical point means a point x equal to c is called critical point of f if f dash c equal to 0 or f dash c does not exist. So if f dash c equal to 0 for any c, then that c is called critical point of f. If f dash c is equal to 0, then that c is called critical point of f. The condition f dash c is equal to 0 is not sufficient for f to have an extremum at c. It is not sufficient. The derivative may vanish or may not exist, and the function may have no extremum at that point. So this is not the sufficient condition. This is the necessary condition. That's why we write if it has extremum, then f dash c equal to 0. If f dash c equal to 0, then you cannot say that f has an extremum. Okay, this is conversely it is not true. If f has extremum, then that implies f dash c must be 0. This is your necessary condition. This is not sufficient. This is your necessary condition. But if f dash c equal to 0, if you conversely write, if f dash c equal to 0, this does not imply that your f has some extremum. That does not imply f has an extremum. Okay, but if f has extremum, then we can say f dash c equal to 0 for some c. Now the sign test for maxima and minima. So we can test also using your first derivative test, using second derivative test. We can find the maximum and maxima and minima of a function. So what is the sign test? This is also called first derivative test. So what is the sign test? So let C be a critical point of f where f is continuous. Suppose C is the critical point. How to find the critical point? Just take f dash C is equal to 0. Take f dash C equal to 0 and solve for C. Then solve for C. So that C will be the critical point. Then to test for the maximum, if there exists a delta greater than 0 such that f dash x greater than 0 for all x belongs to c minus delta to c. That means this is your c, then c minus delta means this is your c minus delta. That means left to the c. Your f dash x less than 0. And for the right part, that means this is your c plus delta. So for c minus delta to c, in this area your f dash x greater than 0, and in this interval your f dash x less than 0. F dash x less than 0 for all x belongs to c to c plus delta. So c to c plus delta f dash x less than 0, and c minus delta to c f dash x greater than 0. And we know that f dash x greater than 0 means what? It is increasing. In previous class, we already discussed if f dash x greater than 0, then function is increasing, and f dash x less than 0 means it is decreasing. It is decreasing, and this is increasing. So that means we can say that if C is the critical point, then for the maximum, if f of C is maximum, then your maximum value, how it will behave. If it is C, then for some delta greater than 0, this is your C plus delta, and this is your C minus delta. So f dash x greater than 0, f dash x greater than 0, that means it is increasing, that means it will be increasing. This type of curve we will get, increasing. Then for C to C plus delta, that means towards the right hand side of C, f dash x less than 0, that means it is decreasing, that means like this. So your curve will be like this. Firstly it will be increased, then after C it will be decreased. If this type of behavior will be shown by the graph of the function f, then you can say that this will be C is the critical point, this is your C, then f of C will be the maximum. You can see also this type of, this is your extremum value, this is your extremum value, and this will be maximum value. If you check the graph, this will be the maximum value, this will be the maximum value. So first it will be increasing, then it will be decreasing. That means it will be positive. First it will be positive f dash x, and then your f dash x will be negative. So they have different sign. First positive sign, then it will be negative sign. Towards the left, means to the left hand side of C it will be positive, and to the right hand side of C it will be negative. Okay, so that's why it is written as f dash x changes its sign. F dash x changes its sign from positive to negative. From positive to negative as x passes through C. As x passes through C. That means if we move from C minus delta to C passing through C, then the sign of f dash x will be changed, and it will change from positive to negative. Positive to negative. First we will get positive, then after C it will be negative. What it will be? It will be means it is for f dash. F dash will be positive and f dash will be negative after C. Then for minimum, just it will be opposite. Minimum means to the left hand side of C. That means from C minus delta to C, in this interval f dash x is less than 0, and for C to C plus delta, that means towards the right hand side of C, this is your greater than 0. That means Firstly, it is your C, this is your C minus delta, this is your C plus delta. So for C minus delta to C, it will be less than 0. That means it is decreasing. Decreasing means this type of curve we will get. This type of curve we will get decreasing. Then after C, it will be greater than 0. Greater than 0 means it will be like this. Okay, first it will be negative, 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 then it will be positive. Is not it? So this is your f dash c, this is your c, then this will be f dash c, and this is your minimum value of the function. Okay, so your sign will be changed from negative to positive. Negative to positive. So if your f dash x changes its sign from negative to positive as x passes through C, then we will get the minimum value of f. We will get the minimum value of f, and that is that occur at C, and the minimum value is f of C. That will occur at C because C is the critical point. That is your extreme point, or it is also critical point. So at that point, the function value will be minimum, and the minimum value is f of C. Okay, so you just remember, for the minimum value, f dash x changes its sign from negative to positive, and for maximum value, f dash x changes its sign from positive to negative. It is for maximum case, this is for maximum case, and negative to positive, this is for minimum case. Okay, so what we got? For minimum means if f dash x changes its sign, this is your f dash x changes its sign minus to negative to positive, then it is the case of maximum. This is the case of maximum, and it is negative. Yes, negative to positive, this is your maximum. And if your positive to negative, if f dash x changes its sign positive to negative, then this is the case of minimum value. Okay. Next come to the slide. This is your minimum test. Maximum, then negative to positive, this is your minimum. Next, how to apply these sign tests in our problem. Let's see one of the example, that is f dash x. Suppose f dash x is this. Suppose f dash x, suppose your f dash x is equal to this. Suppose f dash x equal to 3 into x minus 1 to the power 4, x plus 2 whole cube, 3x plus 2. Suppose this is your f dash x. So to find the critical point, take f dash x is equal to 0. Take f dash x equal to 0, and if you solve, then what we will get? X equal to 1, x equal to minus 2, x equal to minus 2 by 3. That means how? This factor will be 0, x minus 1 to the power 4, then it will be x equal to 1. Then from this factor, x plus 2 whole cube, then we will get x equal to minus 2. And if you take 3x plus 2 equal to 0, then x will be minus 2 by 3. So which are possible extremum points? That means we will get 3 extremum points. At these 3 points, we will check where function is maximum or function is minimum. So the function is continuous at all these points. So first at x equal to 1, we will check. So at x equal to 1, so what we have to check? Means to the left hand side of 1, to the right hand side of 1. So for the left hand side of 1, we have to check f dash x. We have to check the sign of f dash x. So for the left hand side of 1 means 1 minus delta. Okay, 1 minus delta. So this is your f dash x. This is your f dash x. This is your f dash x. So for f dash x, put 1 minus delta. If you put 1 minus delta here, 1 minus delta here, in place of x just put 1 minus delta. Then we will get this person. We will get this term. Okay, minus delta to the power 4, 3 minus delta, and just keep in your mind that delta is very very small, but it is greater than 0. Delta is a small number, very very small, but it is greater than 0. That means it may be 0 0.01, 0 0.001 like this. It is greater than 0, it is positive. It is greater than 0, but it is very very small. So, if I put 1 minus delta in place of x in your f dash x, then we got 3 into minus delta to the power 4, 3 minus delta q, then 5 minus 3 delta. Then if you check the sign of these terms, what we will get? Minus delta to the power 4, that means it is always positive. Then 3 minus delta means delta is very small, so 3 minus delta is a positive number. Then its q, it is also positive. Then 3 into delta, delta is very small, so 3 into delta, it is always small. So 5 minus 3 delta, so 3 delta will be less than 5, so 5 minus 3 delta, it is also positive. So all the factors are positive, so the total term f dash of 1 minus delta is positive, greater than 0. Then check for the right hand side, that is for 1 plus delta. Similarly, find f dash 1 plus delta. So f dash 1 plus delta means just put 1 plus delta in place of x. Put 1 plus delta in place of x. So we got this. And check for the sign of these terms. So delta to the power 4, 3 plus delta, it is positive, 5 plus 3 delta, it is also positive. So all are positive, so product of the factors will be positive, so it will be also positive. So we got f dash 1 minus delta is positive, f dash 1 plus delta is also positive. That means this is your 1, then from left hand side it is positive, and also to the right hand side of 1 it is also positive. So no changes of sign. There is no changes of sign. So it does not change sign as x crosses to 1. So if there will be a change, then extremum will exist. Extreme points will exist, but extreme value also exists. But here there is no change of sign. No change of sign. F dash x does not change its sign as x passes through 1. So there is no extremum. In this case, there is no extremum at x equal to 1. If there will be a change, then extremum will exist. It may be maximum or minimum. But if there is no change, then there is no extremum. So x equal to 1, at x equal to 1, f has no extremum. Okay. But these are the possible. When we took f dash x equal to 0 and we solve for x, we got 1, minus 2 and minus 2 by 3. These are the possible cases. At that points, your function may be extremum, may not be extremum. So that's why we check. And in the checking, what we got? After checking, we got there is no changes of sign. So there is no extremum at x equal to 1. Come to the next point. At x equal to minus 2, at x equal to minus 2, x equal to minus 2 means we have to check the left hand side of minus 2, that means minus 2 minus delta, and to the right hand side, that means 2 minus 2 plus delta. For both we have to check. So for minus 2 minus delta, just see, for minus 2 minus delta, f dash, so just put x in place of x and we got this term. And here after putting x equal to minus 2 minus delta, we got these terms. So check, minus 3 minus delta whole to the power 4, it is positive, whole to the power 4 means positive. Then minus delta whole to the power q, so minus delta to q means minus q, minus 1 to the power q, so it is negative. And 4 minus 3 delta, 4 minus 3 delta, okay, 4 minus 3 delta, so it is, So it is positive, is not it? It is positive. That's why it is less than 0. Actually, it is less than 0, but it is also printing mistake, I think, because minus 2 minus delta, we got minus delta to q, then 4 minus 3 delta. So 4 minus 3 delta means it is positive, minus delta q is negative, so positive, negative, positive. So it should be less than 0. Similarly, for minus 2 plus delta, see here, this is positive, this is also positive, and this is your positive. So it is greater than 0. Greater than 0. So it is negative, this is your positive. So less than greater. So your sign changes from negative to positive. Negative to positive. Your sign changes from negative to positive. Okay, negative to positive, not positive to negative, negative to positive. It is printing mistake actually. Negative to positive. So if it is negative to positive, then negative to positive, then what will be the negative means? This is your maximum. Sorry, decreasing, then increasing, decreasing, then increasing. So it will be minimum actually. This case it is also, it is actually minimum. This is printing mistake. This is actually minimum at x equal to minus 2. Negative to positive, because already we saw in the formula negative to positive means this is your minimum case. Okay, and similarly we can check for x equal to minus 2 by 3. For x equal to minus 2 by 3, put the minus 2 by 3 minus delta, then put minus 2 by 3 plus delta. So minus 2 by 3, it will be, I think it will be greater than 0. Actually it is opposite to this. This is greater than 0 and this is less than 0. And if we got like this, already if we got like this, then it will be changes, means your sign changes, it will be positive to negative. It is positive to negative, so it is maximum. So because it is written as minimum, but it will be maximum. Just printing mistake, sorry. Just do yourself, just see how it is your sign changes. Just solve for this, whether these are correct or not. I think I have some mistakes, so just solve for this. Put minus 2 minus delta, then put minus 2 plus delta. Just see whether it is positive or negative, and if it is positive to negative, then it will be maximum. If it is negative to positive, it will be minimum. Actually, where I saw in these terms, it is negative, then it is positive, then negative to positive. In this case, it is negative to positive, and in this case, it is positive to negative. Just check yourself, and if it is positive negative, then it will be maximum. If it is negative to positive, then it will be minimum. Okay, positive to negative, minimum, is not it? Then negative to positive, then maximum. Okay, positive to negative, it will be maximum, and negative to positive, it is minimum. This is for minimum, and positive to negative, it is for maximum. Okay, so check yourself whether I am correct or not. Just see. Now this is another type of test, second derivative test. This was first derivative test or sign test. Then also you can find the maximum value and minimum value using second derivative test. So what is the second derivative test? What is the second derivative test? That find the second derivative of f. Second derivative of f. That means 2 times derivative. So first, if f dash c equal to 0 and f double dash c less than 0 at that point, then this will be maximum. And if f dash c equal to 0 and f double dash c is greater than 0, then it will be minimum. This is the formula we have to remember. Just find first f dash c equal to 0, then solve for C, then we will get the possible extreme points. Then at each point we have to check whether f double dash c less than 0 or greater than 0, whether your f double dash c greater than 0 or less than 0. If it is greater than 0, then it will be minimum. If it is less than 0, then it will be maximum. Okay, this is the second derivative test. So come to the example. This is one of the example. Find the maxima and minima of this function. Find the maxima and minima of this function. So what is the function? Fx equal to sin x plus x, sin x plus cos x, and the interval is 0 to 2 pi. So in this interval we have to check. So first we have to do what? F dash x equal to 0. So f dash x will be cos x minus sin x. So take f dash x equal to 0. Okay. So cos x minus sin x is equal to 0. So tan x is equal to 1, and then x will be pi by 4. Then pi by 4 plus pi, because our interval is 0 to 2 pi. So within this we have to take the points. Don't take greater than 2 pi. So in between 0 to 2 pi we have to take the points. So tan x equal to 1 means x equal to pi by 4 or pi by 4 plus pi, because the period of tan x is pi. So pi by 4, at pi by 4 it is 1, also at pi by 4 plus pi it is also 1. So what are the possible points, extreme points? Pi by 4 and pi by 4 plus pi. These are the two possible extreme points. So at these 2 points we have to check whether it is maximum or minimum. So what to do next? Take the double derivative, take the second derivative. So what is the second derivative? Again differentiate this. So again differentiate cos x means minus sin x, then minus sin x means minus cos x. So this is your second derivative. So check this second derivative is greater than 0 or less than 0 at each point. So at pi by 4, just check. So at pi by 4, f double dash will be minus, just put x in place of pi by 4. So minus sin pi by 4 minus cos pi by 4. Sin pi by 4 is 1 by root 2. Cos pi by 4 is also 1 by root 2. So minus 1 by root 2 minus 1 by root 2. So minus root 2. If you add this, it will be minus root 2. So minus root 2 means it is less than 0. So if it is less than 0, so it has local maximum. So at x equal to pi by 4, function has a maximum. So what is the maximum value? What will be the maximum value? Just put pi by 4 in f. Maximum value will be f of pi by 4. Just put pi by 4 in place of x. Sin pi by 4 plus cos pi by 4. This is the maximum value. This is the maximum value. Okay, this is the maximum value. Put pi by 4 in place of x in f. Similarly, at pi plus pi by 4. Pi plus pi by 4 means this is the another extreme point. Pi plus pi by 4. So it will be 5 pi by 4. So just put f double dash 5 pi by 4. Find f double dash 5 pi by 4. So it is minus of minus 1 by root 2 and minus of again minus 1 by root 2, and solve for this, and it will be root 2, and which is greater than 0. And if it is greater than 0, then we have a local minimum at that point, minimum at that point. So this is the extreme point, that is, this is the minimum point. And what is the minimum value? Just put f, put 5 pi by 4 in x in f. Okay, so find the value of f at 5 pi by 4. So minus root 2. So minus root 2 is the minimum value. So we got what? At 5 it has maximum value, at 5 pi by 4 it has minimum value. So this is the way to find out maxima and minima using second derivative test. So what to do? This is the procedure. What is the procedure? Again I repeat that first find f dash c equal to 0 and solve for c, and that will be the possible extreme points. So at each point find f double dash c. At each point find f double dash c. At each point find f double dash c. If it is less than 0, then it has maximum. If it is greater than 0, then it will be minimum. And at that point, you can find maximum value and minimum value. So this is about second derivative test to find out maxima and minima, or maximum value or minimum value of the function. Then come to concavity and convexity and point of inflection. Okay, so as we move along the curve y equal to fx, as we move along the curve y equal to fx, if the tangent line rotates clockwise, slope decreases and f double dash x less than 0 on an interval. So the curve is concave down. Curve is concave down. That means convex with respect to x axis. Okay, this type of concave down like this. Again, if tangent line rotates anticlockwise, that means slope increases. Tangent line, it will be anticlockwise like this. Tangent line will rotate anticlockwise. Tangent line will rotate anticlockwise. That means your slope increases. So your f double dash x greater than 0. Here f double dash x less than 0. So f double dash x greater than 0 on an interval, the curve is concave up, convex upwards. So the point where the tangent changes its direction. So the point where the tangent changes its direction, where the tangent changes its direction of rotation, that means where f double dash x changes sign, then it is the point of inflection. This is the point of inflection. So for concave down, you see, just remember, for concave down, f double dash x less than 0. For concave up, your f double dash x greater than 0. And the point where f double dash x changes sign, then this is the point of inflection. Okay, another definitions you can say like this also: concave up, that means convex. A function f is concave up on an interval I if for every x belongs to I and small h greater than 0, f of x plus h minus f of x greater than f of x minus f of x minus h. Okay, equivalently, when f is twice differentiable, f double dash x greater than 0. If f double dash x greater than 0, then function is concave up. Function is concave up. And if f double dash x less than 0, then f is concave down. This is your concave up and this is your concave down. So now point of inflection, the point x equal to c. The point x equal to c is a point of inflection if f is continuous and the concavity changes at c. That means f double dash changes sign across c. Okay, so the point where concavity changes. The point where concavity changes. That means if this is the point and like this. If it is concave, then again like this. And this point is called where your changes. Where your concavity changes, this point is called your point of inflection. Okay, so these are some formula, these are some trick to find out the concavity using second derivative test. Already I told, if f double dash x, if f double dash x greater than 0, then for all x in the neighborhood of c, then f is concave up. F is concave up near c. If f double dash x greater than 0. If less than 0, then concave down. So to test the inflection, to find for inflection points, then take f double dash x equal to 0 and or it does not exist. The point where f double dash x is 0 or f double dash x does not exist. So check the sign of f double dash x on either side of each point. If sign changes, then it is a point of inflection. If the sign does not change, then there is no point of inflection. So if f double dash c equal to 0 alone, if f double dash c equal to 0 alone does not guarantee an inflection, you must check the sign change. You must check the sign change. If sign change, your sign will be changed, then point of inflection exists. Okay. Okay, so come to an example, you can easily understand what is the point of inflection, how it is behaves. So suppose function is fx equal to x cube. Suppose function is fx equal to x cube. Then what will be f dash x? 3x square. What will be f double dash x? It is cxx. So take f double dash x equal to 0 for your to find the inflection point. So if f double dash x equal to 0, then 6x is equal to 0. If 6x is equal to 0, then x will be 0. So at 0 we have to check. So for x less than 0, that means it is negative. If it is negative, then f double dash x is also negative because it is 6x. So if x is negative, then 6x is also negative. So for negative x, your f double dash x is also negative. That means towards your left hand side of 0, it is negative. Then if it is greater than 0, then it is also f double dash x is also greater than 0. That means towards right hand side, it is positive. So it changes the sign. The sign of f double dash x changes from negative to positive, from negative to positive, from negative to positive at x equal to 0. So at x equal to 0 is a point of inflection. So that x equal to 0 is a point of inflection. That means to the left hand side it is negative, to the right hand side of 0 it is positive. So that's why the negative means your sign of f double dash x changes. So that means x equal to 0 is the point of inflection for the curve y equal to x cube. For the curve y equal to x cube. Okay, come to next. This is also, now you can find linearization and error estimation. Your derivative also helps to find the linearization. It is also actually it is not, this is out of syllabus. This is not in the syllabus of +2 classes. So for higher classes you can check Lx equal to f of a and plus f dash a into x minus a, which approximates f near a, which approximate your f near a, and the differential dy equal to f dash x into dx. So for example, if to approximate the value of f root over of 4.1 using fx equal to root x. Suppose fx equal to root x, then at a equal to 4 we can approximate the value of square root of 4.1. Suppose we take fx equal to root x, then your f dash x will be 1 by 2 root x, and what will be the Lx? Lx will be f of a. F of a means f is your root x. So a equal to 4. So it is root over 4. That means 2 plus f dash a. F dash a means a equal to 4. So in place of x put 4. So 1 by 2 into square root of 4 means it is 1 by 4 into x minus a. X minus a means x minus a means your x is your 4.1. So 4.1 minus a means 4. Okay, so the value is 2 plus 1 by 4 into 0.1, and that is your 2.025. 2.025. So this is the approximate value of 4.1 square root of 4.1. So this is how we can approximate any value, okay, using the linearization formula. Okay, so thank you. This is all about your application of derivatives. So if you have some questions, you can ask in our comments, and for the betterment of the classes, you can also suggest anything what you want. Thank you everyone. Again we will meet in another class with a new concept of the mathematics. Thank you.